And this semester we had 3 groups of 3 students each. The first 2 presentations are kind of an industrial hygiene, noise slash airborne particulate exposure flavor. And then this third one is an ergonomic review of a local bacon not fabrication, but let's say bacon processing facility. Then the last 2 presentations are from Auburn. I'll say a little bit more about those when the time comes. So again, the first 3 presentations are the end projects of these 3 groups. And these 3 presentations, this is kind of the practice run, or it's the second practice run because we did it last week also in class on Friday, will be made to the companies, and then there'll be some coordination between the teams and the companies at that point. So I'll turn the time over to our first group, which is going to deal with noise and dust hazards I think we're saying detergent, are we not? Or liquid packages of detergent. Yes.
All right. So I'm Andy Phillips. This is David Wu and Ron Tomyn. And as Dr. Bloswick noted, we'll be talking about noise and dust exposure associated with the production of single-dose liquid packets. So the goals of our study were to measure both noise levels as well as dust concentrations in the production of single-dose liquid packets, which is an innovative product which this household manufacturer has recently developed, as well as propose recommendations regarding implementations of possible abatements to these noise levels and dust concentrations. So a little background on the production of what we were evaluating. So this household product manufacturer developed these packets, which are pictured here. They're plastic shells within which is a specific dose of the liquid, either laundry or dish detergent. And it's a large manufacturing warehouse, and in order to provide adequate space for the machinery associated with the production of this product, they created a new room to house all the machinery and to allow sole production of this single-dose detergent packets. The setup of the room is as such. This was mapped out by our team. There are 4 main stations that are outlined on this map. Number 3 would be where the dose is injected into the plastic shells in the bottom corner there. The packets would then go through a conveyor belt to site 2, which is the Talc Generator. So a talc powder gets put onto these plastic shells so that the friction between the various packets would be less and they wouldn't stick to each other, so that it could get appropriately separated into the containers, which occurs at site 1. Which is the single-dose packet distributor. That's where they get separated into the appropriate number for each container to be sent to the distributors. Site 4 there is a computer station which one of the workers will be rotating throughout the course of the day in order to do various analysis of the product. So this is just a quick nutshell of the process that occurs there. The detergent dose gets sealed in the plastic shell, and then, as we mentioned, it gets powdered with that talc to allow for separation during the packaging into the containers. In addition, that powder also prevents them from adhering long-term, so that when the consumer buys the product, they don't have to rip them apart, potentially losing functional use of some of those packets. So we were asked to do a evaluation of this room, of this workplace, in particular to evaluate the talc exposure, that powder exposure, given that such dust exposures can lead to respiratory illness. The safety data sheet that the company provided us with regards to the makeup of that talc demonstrated it to have 0.1% quartz silica, which is important because of the potential for development of silicosis in the workers associated in this area. In addition, we evaluated the noise levels, given that high noise levels can lead to both hearing loss as well as other health effects.
So since this was a newer process, and since the single dose room was created to accommodate this process, there was no blueprint or outline of the dimensions of the room. So before we could even start collecting our data, we had to physically measure the parameters of the single dose room to understand the areas we'd be sampling in. once we measured this room, we decided to use a 5 foot by 5 foot area for each sample. This equated to a total of 96 sampling sites. And as you can see here, each of these numbers represent one 5 foot by 5 foot area. So we first performed a dust survey, and we performed a dust survey for both total and respirable dust. The instrument that we used was a GRIM 1.109 aerosol spectrometer. And as mentioned before, our sampling area for each sample was a 5 foot by 5 foot area. So these were grab samples that we took, so each sample lasted a total of 40 seconds. And as mentioned before, we did a total number of 96 samples in the single dose room using this GRIM. We attempted to our best of our abilities to take it from the center point of the 5 foot by 5 foot area, but depending on machinery or certain barriers, we did the best we could to sample at that center point for uniformity and a standardization of sampling. Likewise, we performed a noise survey, which was a similar method in our dust surveying. For the instrument for noise surveying, we used a Larson Davis Soundtrack LXT sound level meter. And again, it was a 5 by 5 area. And instead of a 40-second sampling time period, we used a 15-second sampling time period. And we, again, had a total number of 96 samples taken for our noise surveying. And likewise, we sampled at the center of their 5 foot by 5 foot area to the best of our abilities. After the data was collected, we then could download the data from these instruments onto the appropriate softwares. Once the data was downloaded, we could then input this data into a software called Noise at Work to generate what is called an isopleth. An isopleth is a mapping of the different levels or concentrations throughout the noise, throughout the single dose room, which will be shown later in this presentation. So for dust, a total and respirable dust isopleth was created. And to just define our parameters for total and respirable dust, for total dust, our parameters were 0.22 to 32 micrograms. And the reason for that was due to the parameters of our GRIM instrument, that it could only measure from 0.22 to 32 micrograms. For respirable dust, it was everything equal to or less than 4 micrograms. So it would be 0.22 to 4 micrograms in this case. For our noise surveying, we created 3 different isopleths, again, using Noise at Work. These were an LEQ, an L-peak, and a 4 kilohertz isopleth. To give a definition of each of these 3 to help better understand what they are, an LEQ is an equivalent continuous sound level, and this is what is most commonly used when noise is measured and noise is surveyed, is our LEQ. An L-peak is the maximum value recorded for the sound pressure peak. This is an instantaneous sound pressure peak that is recorded. 4 kilohertz is the frequency at which human hearing has the greatest, at which humans have the greatest hearing loss. So that's why these 3 were selected to be used for our isopleth.
So moving on to the dust results, again, the air monitoring was done using the GRIM aerosol instrument. And as you can see, the average for the total dust is 0.25 milligram per meter cube of air. And that ranges from 0.03 to 1.11 milligram per meter cube of air. And even though our samples are not 8-hour of 8-hour duration, it's comparable to the OSHA PL of the 8-hour time-weighted average if all the conditions stay the same. So compared to the OSHA PL of 15 milligram per meter cube, it's quite low, what we have. And then for respirable dust, the average was 0.16 milligram per meter cube, ranges from 0.02 to 0.74 milligram per meter cube, and that's compare that to the OSHA PEL of 5 milligram per meter cube. And here is our first isopath, referring to the total dust. The greatest concentration that we found was actually below the detergent injecting machine. It's actually far away from where the talc generator is, and we have yet to find out the cause of that, since there are no powder generating machinery in that area. And then the second greatest area is actually close to the talc generator, as we expected. And for respirable dust, it's very similar, with the greatest area, dust concentration area, being below the detergent injecting machine, and then the second greatest area being close to the talc generator. As far as our noise results goes, we got these results using the noise graph samples, as Ron alluded earlier. The average LEQ level was 83 dBA, with a maximum 91 dBA, and that is compared to the action level of 85 dBA of OSHA. Once again, these noise graph samples were less than a second. However, they were comparable to the OSHA TWA if all the conditions were the same and they did not change. For L peak, the average was 100.6 with a maximum of 110 dBc, and then compared to the OSHA PEL of 140 dBc. And then for the 4 kilohertz, the average was 77.2 dBA with a maximum 99.5 dBA, and then again comparing that to the OSHA action level of 85 dBA. So for the LEQ isopath, it shows the greatest noise concentration or level to be close to the talc generator, extending down to the detergent injecting machine. For the L peak, it actually is different. It shows the greatest noise level to be where the single packet distributor is. That's where all the single packets were loaded into a container. And then the second greatest area is where the talc generator is. And then for the 4 kilohertz frequency, the greatest noise level is actually above where the talc generator is.
All right, so in terms of recommendations, as David just noted, the dust concentrations in this room were well below the OSHA PEL. So therefore, we did not feel that any engineering abatements would be, any additional engineering abatements would be required. There is a local exhaust ventilation system directly adjacent to the talc generator, and continued calibration of that ventilation system would be appropriate to continue to maintain levels as we measured. In terms of future evaluations, we would recommend doing a full 8-hour samplings to get a exposure which would be more representative of what the workers would be experiencing on a daily shift basis, which would also allow us to compare more directly to those standards which we discussed earlier. In addition, it would be helpful to do a silica analysis of the talc in order to compare whether the SDS was consistent with what we were experiencing. In addition, it would also give us that data to see what the shift exposures would be for each worker in that area. And then finally, as David mentioned, with regards to the isopleth of the dust exposures, there was that peak of increased dust concentrations, still well below the standards. However, it was unknown as to why there would be a peak in that region, so evaluating that would be wise. In terms of the noise levels, in various areas of the single-dose packet room, there were sound levels which were approaching and exceeding the action level, and that would require some abatements. We discussed some possible engineering abatements, such as encasing those machines that we talked about earlier in plexiglass for a sound barrier to decrease the noise level in the room. However, it would be a very expensive process. And in addition, this is one room in a very large production warehouse, and so they would still have to wear hearing protection in those other areas. So when we did a full cost-benefit analysis, we felt that there would be minimal additional health benefits over the current practice. And that current practice is this company has a hearing conservation program with all the appropriate testing of workers' hearing and that, as well as requiring workers to wear hearing protection in all areas of active manufacturing. And given that that policy is comfortable to the workers already, and that doing any engineering abatements in this room would not change the exposures or the levels in other areas, it was felt that continuing this current practice would be most beneficial. In conclusion, we measured the noise levels and dust concentrations in the single-dose liquid packet production room, and our final recommendations were to continue current practices without need for additional abatements at this time. We'd like to acknowledge and thank the company which allowed us to perform the evaluation, to go in and to work with their workers in order to do our various testing. Also our faculty members, Drs. Eric Wood, Leon Bloswick, and Leon Pahler, as well as the Rocky Mountain Center for Occupational and Environmental Health, as well as the NIOSH for providing our training grants. Are there any questions?
Yes. We did not get a chance to look at those results. Yeah, it could be something we could do, but at this point we haven't even asked if they would be willing to share that information with us. It's also important to mention that noise dosimetry wasn't performed because they had just recently performed the noise dosimetry to a third party to perform that. So we simply, we weren't really involved in any of the actual 8-hour exposure, the time weighted average for that. But yeah, we did not look into the audiometric testing either. So, yes.
Did you look at the hearing protection areas and then compare the audiometric or the octiband noise reductions that's offered by the hearing protection to the noise that's actually present?
Yes, we did look at the noise reduction ratings and with the octiband analyzer. That was more extensively described in our actual paper that we wrote. But yes, we did look at that and found it to be sufficient. So. Yes.
How did you establish your grid? Did you place markers at the corners, or did you estimate the state measure?
Yeah, that's a good question. So in the methods that I forgot to mention, we actually had one of us actually handle the instrument, another was recording information, and the third was actually doing the physical measuring of our 5x5 grids. So yeah, that was a good question. All right.
Oh, sorry. Go ahead.
Yes. Yeah, so I believed in 40 seconds it was about 7 data points, 7 or 8. And then what we did was if there was maybe 8, I'm pretty sure it was 7 data points, but we averaged the 7 data points and we're consistent with that through all of the GRIM data. So we just averaged that out for all of them. But yeah, it was about 7 data points for the 40-second time period. So.
Okay, let's thank our speakers.